Has anybody heard about open data? Yeah? Has anybody worked with it? Yeah. This talk is about query language. Query language, which was developed in 1994, but only recently I took that idea and implemented and created a tool which is useful. So I'll try to go through different ideas behind that query language, which helps to combine data sets of various structures, forms. It's very, very flexible. Before we go into details of the language, I would like to talk about the challenges which are frequently faced when working with open data. One of them is the variety of structures. You probably know that there are so many different file formats: JSON, CSV, XML, and who knows what. All of these structures, it's very difficult to maintain, it's difficult to parse. You always need to write a different parser, and you need to try to put it together somehow. So that's one of the problems. Another problem is that there are different ways to identify things. Different companies use different ways to identify things, so different people even do it. For example, IBM is usually called International Business Machines, or just IBM, or just Big Blue. All these three things are representing the same entity, yet you need to be able to figure out how to bind these entities together. Comp has some mechanisms which help to deal with this. One of them is the approximate string matching, and another one is the famous regular expressions, so you can use those things. And units of measure, we still have different units of measure: meters, feet, and so on and so on and so on. So how do we work with the data today? If you're very, very lucky, you can use one of these commands: grep, sed, awk, or jq, that's for JSON query, or the xslt proc if you have some crazy XML data, if it still happens. But this is luck. In most of the cases, that's how it ends up. You open your editor, you create your program, you write the code which will take the data from different files, try to process them, iterate through them, combine them somehow, and you close it and you hope to never come back to that again. So it would be nice to have something which we can reuse, something which we can share between each other, reuse, and to build upon. So first of all, let's look at some of the popular data representations. Here I'll cover primarily two types of data. This is the tabular data and the hierarchical data. There are also graph data sets and some very complicated algorithms to process graphs, but this is more of an exception. Most of the open data comes in two forms, either tabular or hierarchical. Tables are probably very familiar to many people. Relational databases use the tables, and usually you split the data into several tables so that you don't have repetitions. So there are two random tables. One of them represents the attendees. People, basically the table on the left represents the people who are attending the conference. So it says that user ID 1 with name ABC attends RubyConf 2013. And another table would be, let's say, conferences. It says that the RubyConf 2013, that's the identifier of the record. It has that URL, and it started on that date. And so on and so on and so on. Hierarchies are fairly different. There are many people complaining about hierarchies. I was one amongst those people, actually. But the interesting thing about hierarchies is that they usually fold the data into the most usable access path. It means that you can very quickly get the data you're actually interested in. So the same two tables we looked at before. One of them is the conferences, and another one is the attendees. They could be folded into two different ways. And actually, this example illustrates some of the problems with folding. So in one case, you can have the root element. By the way, when I talk about hierarchies, it doesn't mean that it's JSON. It doesn't mean that it's XML. It's any kind of a hierarchy. So one of the ways to fold that data would be to use conferences as the root element. This will be just a list of different conferences. Then conference will be some object or something which will have several attributes: URL, start date, name, and then it might have attendees list below. Here you see it's a classical issue. You'll have duplicate attendees. Those attendees who attend different conferences, they'll be duplicated. So some people will try to do it that way, as presented on the right. They'll have attendees as one of the, let's say, root elements, one of the elements, top-level elements, and then they will have some structure below it, like the same one, name, conference. And then you might have another top-level element called conferences, where they have conference URL and name. And then they will try to bind somehow this conference on the left to the conference here. So basically, to figure out which attendee attends which conference, you'll need to do this hops, transform the data all the time. So this is something we see most frequently. Oh, excuse me. Okay, so is there something in common between those two structures? Let's look again. So if you look at the table, one of the ways to look at it is as a list of objects with 3 attributes: user ID, name, and conf. I say one of the ways because the most proper way to look at tables is actually as sets, unique, unordered collections of elements. But nevertheless, by abstracting the tables this way, it will help us to find something very interesting. We'll come to that very soon. With hierarchies, it's the same story. You can look at it as a list of objects, conferences in this case, excuse me, conferences. Each conference will have 3 attributes, URL, name, and attendees. And attendees might be a complex attribute which will itself contain a list of strings which represent names of the attendees. So lists and objects, this is all very interesting and probably very familiar to you. But how can we formulate queries, and how can we formulate queries in such a way that we can combine these 2 different worlds? List comprehensions. Ruby has this construct. I'm sure you are aware of that. And in 1994, Peter Buneman and a lot of other people, they were doing a research in query languages. And they came up with this brilliant idea that they can use the comprehensions to query structures of absolutely various forms, be it tables, hierarchies, and so on. So what is a comprehension? Comprehension, in this case, I use the construct implemented in the tool I'm talking about. It's called comp. The syntax is borrowed from Haskell. It's a very simple construct. It's a list of all R, where G1 and G2 and Gn. Basically, you can have one result type here on the left, and here you have different constructs, generators or expressions. What's important here is that each comma represents a logical AND operator. So you can put as many of these generators as you want, and you can create a fairly comprehensive traversal using just one simple construct. That's the core idea. So what are these G1, G2, Gn, and so on? They represent 2 different types of things. In one case, it can be a generator or a binding, and in another case, it can be an expression. A generator is a construct of the following form. It binds the list, basically all elements of that list, to a variable A. So it's like for loop. It's a for loop which binds every record of list to A. Expressions, they're any kind of Boolean expression. In this case, it's just an equality on strings. So a name is Ruby. And here is a very basic example, self-contained example. It says, give me all the elements from the list 1, 2, 3, where I is not equal to, or you can read it as I was doing it before. It's a list of all I, where I is from 1 to 3, and I is not equal to 2. So the result list will be 1 and 3. Let's get back to our more interesting examples where we have conferences, attendees, and so on. So one of the ways we looked at representing the conferences and attendees using hierarchies is this. So the conference is the top-level element. Then you have element conferences, and then within conferences, you have attendees. And then let's try to answer the following question. How do I get a list of all the RubyConf attendees from this structure. I'll give you an example immediately, just walk through it. I think it will be more interesting. So first of all, we use one generators, confs. So that will represent the top level element, conferences, and that will create an iterator of all the elements in confs and bind them to C. So C would be a variable for all the conferences. Then we will select only those conferences which are RubyConf 2013. And after that, we can take those elements from C, attendees, and bind them to A. Basically, this way we iterate through a nested collection within the conferences. Now let's look at the tables. That's something a little bit different. With tables, let's try to answer exactly the same question. How do I get a list of all RubyConf attendees? In this case, we have two tables because somebody tried to normalize it, which is quite frequently, and it's split into two variables, attendees and conferences. The way to structure a query is very similar, as you see. So first of all, we iterate over the table called conferences. This is this construct. So we take confs and bind each element of confs to C. And we pick up those conferences which are equal to RubyConf 2013. And then we take all attendees. It's pretty much for all the conferences, we do all attendees, bind attendees to A, and then we match them based on the equality of the conf ID. In this case, it was RC 2013 and RC 2013. It's a little bit silly example, but on the other hand, it illustrates the join. So this is what in the relational algebra you would do. You would take one collection, then iterate through that collection and try to figure out all the matches. Of course, there are very advanced algorithms which are very efficient in that. There are hash joins, there are sort merge joins, and so on and so on and so on. But don't forget, this is only the implementation. We are talking here only about the query, about the idea of expressing these queries in a very simple way. So overall, you can look at it as hierarchies above. That's iterating and figuring out what are the attendees to the RubyConf 2013, or tables. And what I'm really excited about is that there is only one construct used, comprehension. This is very powerful. And the tool which is built on top of that is called comp. It's on GitHub. And please feel free to download it, fork it, submit pull requests, and yeah, just talk about it. Thank you.